If you've ever wondered how graphing calculators work, it's something called Newton's method, which I'm going to explain in this video. This video is a group project for my math class, ESP 2010.501. And here's my group members. So for this group video presentation project, we had this group of questions, and you can read the rest if you want, but the question I'm going to focus on in this video is explain Newton's method for estimating solutions to equations. And first of all, what is Newton's method? You're probably wondering. So according to Wikipedia, Newton's method is a way of estimating successively better approximations to the roots of a function. So you're given your function is f of x. You're trying to find where that crosses the y-axis. There's limitations to this, which we're going to talk about later. For example, like what if it never crosses the y-axis, or what if your derivative is like 0 and then that messes up everything. But anyway, so it's basically how graphing calculator works. And so when you're using your graphing calculator, you can think of like Newton's method. Newton actually didn't discover it. It was the Babylonians. They discovered a more specific version called the Babylonian method, which is a specific version of Newton's method, but with square roots. So anyway, so how this works, let's say you're given this graph right here. Here's your function f of x. Here's your x1 value. Here's your x2 is where it hits the graph right here, your tangent line. And the distance between your x2 and your x1, let's say that's delta x. So you're given your seed value x1. Okay, well you're trying to find your x2, so how would you do that? You would find an equation using delta x and to find your x2. So this is actually a rearranged equation of, I think it was delta x is x1 minus x2. But yeah, anyway, this is your x2 is equal to your x1 minus your delta x. So let's say you're given your x1 and you're trying to find your x2. How you do that, I explained that. How you do that is using your f of x, your delta x. So first of all, we're going to make this equation like find like where x2 is as close to the root as we can. How we're going to do this is we're going to use a slope, and let's say the slope is your f of x. Let's say it's this equation. So anyway, how would you know this? So anyway, if you look very closely, and you can pause this video at any time if you need to like look at the graph and see how it relates to each other. So here's your f of x1, your seed value input, and so your delta x is your distance between here and here. So you're trying to find your x2, so how you do it is you take your x1 and you divide it by your slope, and so this is just rewritten as your slope. Your slope is your f of x1 over your delta x. You can rewrite it by multiplying this side by your delta x and dividing this by your slope. So you get delta x is your f of x1 over your slope, which makes sense because that would give you your x2. So as you can see, if you know anything at all about calculus, you know that your slope is your tangent line. So your tangent line is this specific line at your x1. You take your tangent at x1 and you plug that in for your slope, so you get your input right here over your tangent line gives you your x2. because that's your delta x, right? And then for the next part, so we're gonna see that this right here, like you can't see it, it was like right here, but your original function right here, your delta x is your x1 minus x2, or like this is your rewritten x2 is x1 minus delta x. You can see that you have your delta x right here. Okay, you found your delta x. So you're gonna plug it into your equation, and you're gonna see that your x2 is equal to your x1 minus this stuff which you plugged in, and that's the equation you use. More general form is if you had, for example, like let's say this is your xn, you do xn minus 1, which in this case is 1, and here's your 1 and 1, and here's your n minus 1. So this is your general form. Let's say if you weren't using 2, if you're using like 5, your 5th term, where n is your like term number. And this is a general form you need to use where it's more than 2. The reason why it has to be more than 2 is because let's say it was your 0th term. Well, your 0th term minus 1, that's not really like going to give you anything. So this is because you have to have an input, and you have to have like, it has to hit the graph somewhere, right? So how do you use this formula to find either one? How do you use it to find your like closest root approximation is you plug in as many successive values of x until your output is so close to the actual root that it's basically the root. So yeah, so you plug in successive like terms, your n increases, and all that. So basically where it overlaps. And as you can see here, here's your function. You're trying to get where these two are as close to each other that they're basically equal to each other, which is minimizing the delta x. So if you look at your graph, you're trying to minimize this value where these two are basically overlapping, and they would overlap over like at this closest this point. I'm going to show this later in a part 2 video, so don't worry. It's gonna be explained. Here's a sample of how it works. Let's say you have your second term, and then you plug it in, and you get this. This is your output. Okay, well that's really close to root, let's say. And then plug in another term, and oh, sorry, you plug in your n2 and you get this. Okay, that's like really far, and then you plug in another term and you get closer and closer and closer and closer until like you're so close you're like repeating. And let's say it's like really accurate now because you get repeating decimal places all the way here. So like this one, it was off by your 8, you went down to 7. Here it stayed the same, stayed the same, stayed the same. Let's say it's really close, and this is here as close as you can get to your actual. And so like for example, like right here you have 5, that's really far off, that's 0.2 off, and the more successive terms you plug in, the closer you're going to see in my next video that this value is going to get closer and closer. Your tangent line where it hits the graph is going to get closer and closer to your actual root. So yeah, so here's my part 2 video. Go and watch it. I'll like explain more graphically how this works. And thank you for watching.